Good morning, good afternoon, and good evening. This is Mr. Payne bringing you Geometric Sequences, Unit 6, Lesson 9. The first formula I'd like to talk about is the geometric formula. A sub n equals a sub 1 times r raised to the n minus 1 power. One of the things that I want us to just go over real quick is what my r stands for. You know how in our arithmetic sequence it was D, and that was my common difference. This is going to be my common ratio. My common ratio is what am I multiplying by in that problem for my pattern change. And I'll go through that with you a couple times. The next formula is the geometric recursive formula. Remember, we had in arithmetic, we had our arithmetic sequence formula, and we had our recursive formula. So I gave you both right up front. A sub I equals a sub I minus 1 times r. Now don't forget that a sub I is just my number. It could say a sub n equals a sub n minus 1 times r. Those are the two formulas we're going to use throughout the video today. In exercise number 2, for each of the following geometric sequence, identify the common ratio, the r, and give the next two terms. So in A, let's see what we're multiplying by. I went from 2 to 6, 6 to 18. Well, you should say that we were multiplying by 3. What's 18 times 3? That gives me 54. What is 54 times 3? Well, that gives me 162. Therefore, my r, my common ratio, is multiplying by 3. B, I went from 4 to negative 20 to 100, and so forth and so on. What is my common ratio for that guy? Let's think about it for a little bit as I fix my lines. Well, I know that I'm going to have to multiply by a negative number. In order to go from a positive number to a negative number, I'm going to have to multiply by a negative. Well, then what times what gives me 20? Well, 4 times 5 gives me 20. So my common ratio must be multiplied by negative 5. Now let's test it. Negative 5 times 20, negative 20 gives me positive 100. Excellent. 100 times negative 5 gives me negative 500. Negative 500 times negative 5 gives me a positive 2500. My common ratio is multiply by negative 5. C gets a little tricky. I went from 16 to 8 to 4. Well, what am I doing? It looks like I'm cutting them in half. So we could say that we're dividing by 2. What's another way of saying divided by 2? I can say it as multiply by 1/2, or 0.5. So what's 4 times 1/2? Well, that's half of 4 gives me 2. 2 times 1/2 gives me 1. So my common ratio is multiplying by 1/2. My r is times 1/2, or 1/2. Exercise number 3. Consider the geometric sequence given by the recursive rule. A. Find b sub 2, b sub 3, and b sub 4. Write each as an extended product to see a pattern, but also find the final result. So the first thing I'm going to do is, like always, is draw my table in for organization. I have term 1, term 2, term 3, term 4. Term 1, they tell me, is 3. Now I'm going to use this formula to continue to find b sub 2, 3, and 4 using the recursive formula. So I'm looking for b sub 2. So I'm going to have b sub 2 minus 1 times 2. 2 minus 1 is b sub 1 times 2. b sub 1 is 3, so 3 times 2 is going to give me 6. b sub 2 equals 6. And we continue that. And I'll do it in a different color just so you can see it. B sub 3 equals b sub 3 minus 1 times 2. 3 minus 1 is b sub 2 times 2. b sub 2 is 6 times 2. b sub 3 equals 12. I would like you to use this pattern and go ahead and find b sub 4 on your own. Hit pause and do that now. Okay, welcome back. I would like you to find out b sub 4 and watch what we're going to do here. b sub 4 equals, and check your work because you should do it. You should have it done already. 4 minus 1 times 2. b sub 4 equals b sub 3 times 2. b sub 3 really is 12 times 2. So b sub 4 equals 24. So that's b sub 2, 3, and 4. Now in B, they would like you to find, based on what we determined the value in A, find b sub 10 and b sub 20. Well, here's the problem. In order to find b sub 10 and b sub 20 using the recursive formula, we have to know b sub 9 and we have to know b sub 19. So unless we want to continue that table all the way through, we have to go and use the just the geometric formula, which is a sub n equals a sub 1 times my rate change n minus 1. So a sub 1 we already know, which is going to be 3. What we don't know is going to be, well, we'll find a sub 10. That's a good point. Let's do that first. A sub 10 equals 3, a sub 1, which is 3. And what is my rate of change? So what did I do from 3 to 6 to 12 to 24? Well, it looks like I'm multiplying by 2. And I can see that by the recursive formula. It tells me right here my rate of change is multiplied by 2. So I'm going to say times 2, 10 minus 1. This is a little hard to see in here. I'm just going to draw a line in here so we can tell where one problem ends. So 2 to the 9th power, because this is 3 times 2. What is 10 minus 1? 9. So 2 to the 9th power times 3 is going to give me a sub 10 is going to equal 1,536. Let's do the same thing to find a sub 20 now. A sub 20 equals 3 times 2 raised to the 20 minus 1, which gives me 19. So let's do that in our calculator. So a sub 20 equals 3 times 2 to the 19th power. How do we get 19th? We did 20 minus the 1. So a sub 20 equals, and this is a really big number, 1572864. 1,572,864. That is a sub 20. I'm going to have you skip exercise 4 for the time being, and we'll come back to that as a class discussion and a class debate. So I want you to go now to exercise 5. It says, for a geometric sequence defined by the following, list and plot the first 6 terms on the grid below. The term that I gave you is a sub 1 equals 16 and a sub n equals a sub n minus 1 times 1/2. And this is a recursive formula. The first thing I would like you to do is go ahead and I created the table for you, so create the table on your own. And I would like the first 6 terms. So 1, 2, 3, 4, 5, and 6. The first term is going to be 16. So now let's go ahead and use our formula to go ahead and find the rest of the terms. If I plug in a sub 2 minus 1, a sub 2 minus 1 times 1 half, a sub 1 times 1 half, a sub 1 is 16. 16 times 1 half is going to give me 8. And then we're going to just continue that down all the way. We're looking for a sub 3 minus 1 times 1 half. A sub 2 then times 1 half, because 3 minus 1 is 2. A sub 2 is really 8. 8 times 1 half gives me 4. I want you now to go ahead and continue that on your own using what I've started for you. Go ahead and hit pause and finish. Okay, welcome back. If you continue doing what I showed you using the recursive formula, you would have found that term 4 is going to give you an output of 2. Term 5 will give you an output of 1, and term 6 will give you an output of 0.5. Now if we go over to the graph to our right, what we have to do is now plot this on the grid. Notice that each value going up your y is worth 2. Each value on your x is going to give you 1. So let's pay attention to that as we graph these. 1, 16, so I'm going to go over 1 up 16. 2, 4, 6, 8, 10, 12, 14, 16. Then 2, 8, 2, 4, 6, 8. 3, 4, over 3 up to 4. 5, 1. And then a half on 6, 1. When you graph this, notice what kind of graph is this? We've learned these before. You should be saying exponential, Mr. Payne, and you do know that it's an exponential graph. Don't forget that geometric sequences grow or decay exponentially. That's the end of your notes for geometric sequences. We're going to touch upon exercise number 4 when you come into class on Monday. Have a great weekend. Enjoy yourself. Stay fresh. Go Bills.